Hello again and welcome back to our course on Excel 2013 Advanced. In the previous sections we've been looking at the use of some of the financial functions in Excel 2013. To see a full list of the functions, if you click on the Formulas tab in the Function Library, there is a section devoted to financial functions, and if you scroll through those, as you know already, if you hover over one of the functions you get a description of what it can do for you, and then of course if you scroll through them you'll see that there are a few of those that we've used already. Now I want to do one other group of examples in this section, and I want to talk in this section about depreciation. So first of all, let's suppose that I'm running a business and I've bought a piece of equipment, an expensive piece of equipment. You're probably aware of the concept of depreciating the value of that equipment over time. What you may not be so aware of is the different ways of going about calculating that depreciation. And that's what we're going to look at in this section. Now the rules relating to depreciation do vary from country to country and from industry to industry, and to a large extent they're flexible wherever they're applied in terms of, for instance, how long a piece of equipment will be expected to last. So the example that I'm going to use here is very much a hypothetical example. Let's suppose that I've bought a piece of equipment for $100,000 and I expect to use that equipment for 5 years. And then at the end of the 5-year period I would normally expect to sell that piece of equipment either as salvage or as a used piece of equipment to somebody else. And what I'm going to assume in this case is that the cost price of the equipment is $100,000 and that the value after 5 years will be $20,000. So first of all, let's put those values on this little scratch worksheet that I'm using here. Now let me draw a chart to show what the depreciation in the value of that piece of equipment is going to be over the 5 years of its life. So we'll start with 1, 2, 3, 4, 5 years. And then in the next column we'll put depreciation. And we're going to use one of the formulae that's available in Excel 2013 to calculate the depreciation. Now the simplest sort of depreciation is what's called straight line depreciation, and the function in 2013 that can calculate that for us is the SLN function. So if we put equals SL, there it is, then it says cost. Now the cost is going to be C2, the salvage value, which is C3, and then the number of years over which we're depreciating this piece of equipment, so that will be C4. Okay, and there we have the depreciation in year 1. Now one thing you'll realise, of course, is that all three of those are going to need to be absolute cell references if we're going to use them for subsequent years. So I'm going to make that change now. Now one thing to note is that the value of the depreciation in each year is not a function of the year. It doesn't depend on the year. It's straight line depreciation. So it will be the same each year. Note how every reference in the arguments for that function is an absolute reference. So if I do a fill down, what I'm going to get, that's Control D, is exactly the same depreciation in each year. Now the next thing I want to do is to build up a chart that shows me the value of this piece of equipment at the end of each year. So for instance, if you take year 1 with an initial value of $100,000 and a depreciation of $16,000, it's going to have a value of 100 minus 16, that's $84,000, and so on. Now I realise that's rather simple arithmetic at this stage, but as you'll see in a while it isn't always quite that straightforward. But let's build up that chart, and I want to do that chart in a couple of ways. What I want to do is I want to put in here total depreciation, and then value at year end. Now the total depreciation at the end of year 1 is going to be F2. What's the total depreciation going to be at the end of year 3? It's going to be equals the total so far, which is G2, plus the depreciation in this year, which is F3. Now notice the formula we've used there doesn't have any absolute values in it. We could of course say $G and $F, but since we're not working across the columns anyway, the column numbers are not going to vary. So if I select G2 and do a fill down, that's fine. And as I can see at the end of year 5, my total depreciation is $80,000. And then it's pretty straightforward to put in a formula which gives me the value at year end. So in this case it's going to be equals to the original cost, which is, let's put these straight in, $C, $2, minus, and now this will be G2. Fill that down. And again I finish up with the correct final value. So that's a pretty straightforward calculation using straight line depreciation. So what I'm now going to do is to do away with column G, and I'm going to incorporate into the formula in each cell in H the whole calculation that I need to do. Now in the case of H2, I don't actually refer to column G at all. I say that the value at the end of year 1 is C2, which is the initial cost, minus F2. F2 is the total depreciation at the end of year 1. If I wanted to express the formula in H3 to not specify column G at all, so instead of G3, what would I put? What I really mean by G3 is this. By G3 I mean the sum of the total depreciation so far, which is the total from F2 to F3, that range. And if I fill that down to the next cell, so I do a Control D, that gives me an incorrect value for the value at the end of year 3, because this now says that the value at the end of year 3 is the initial value, C2, minus the sum from F3 to F4, which is clearly wrong. I really need the sum from F2 to F4. So in fact, this formula should also specify as the start of the range an absolute value. So this should be the initial value, C2, $100,000, minus the sum from F2 to F3. F2 is fixed, it's absolute, F3 varies. So let's now do a fill down for all of the rest here and see what happens. And that now gives us correctly the values at year end for each of the 5 years, and I can now just delete that column. And I don't need the original column G anymore. And if I even wanted to do this in a slightly more elegant way, if I go back to the value in G2, instead of having just C2 minus F2, I could put here the sum $F, $2, colon F2. There's no reason that I shouldn't use the same cell for the beginning and the end of a range, and in this case the reference at the beginning of the range is absolute and the reference at the end of the range is a relative reference. Still gives me the right answer, and of course if I fill down, everything else works correctly as well. So that's straight line depreciation. Now I'm going to leave you with an exercise to do now, but before I set that exercise I just want to change the layout of this worksheet a little bit. What I would like you to do for this exercise is to build up this table to compare straight line depreciation, the one we've done so far, with two other methods of depreciating the value of an asset. There are several provided in Excel 2013, but I just want you to do declining balance depreciation and sum of years digits depreciation. And in each case you need to work out the depreciation for each year, put it in the first column, and in the second column work out a formula to give you the value at year end. Now let's take a quick look at the functions that give us those two values. The first function you're going to need to use is the DB function, the declining balance function. This is not to be confused with the DDB function, the double declining balance function. The principle of the declining balance is that the depreciation is steady, but steady in the sense of a percentage. So for example, in the first year a piece of equipment may lose 20% of its value, and then in the next year it may lose 20% of that remaining value, and then the remaining value after 2 years, in the third year it loses 20% of that. So although the percentage is steady, the amount that it loses in value each year will actually obviously decrease. Now the formula you need will include the function DB, and there you have cost, salvage and life, the three arguments we've looked at already. The period will be the period number, so in the 5-year period 1, 2, 3, 4, 5, you're not going to need that last argument. The last argument is used when you have to allow for a part of a year. So if your company has a fiscal year, and if you're starting this part way through a fiscal year, you have to specify the month number. Now we're just going to assume that we're working in whole years. So we bought this thing at the beginning of a fiscal year, and in the first year we have a full year of depreciation as opposed to part of a year of depreciation. So that's the one to use for declining balance. And then the second depreciation method I want you to look at, the principle here is different. You do get a decreasing amount of depreciation, but it actually works on the principle of adding up the total number in, if you like, the values of the digits in the years. So the first year counts as 5 units in a 5-year depreciation, the second year is 4 units, the next one 3 units, and so on. And those numbers of units determine the proportion of the overall depreciation that can be attributed to each of the years. Now you don't really need to understand exactly how that works, although there's a formula down there, and in all cases there are a couple of examples. But what you do need to know is the function, and the function is pretty straightforward: cost, salvage, life and period. So they're the two functions you need to use. I'm going to leave you with that one to do. I've saved the worksheet as it is now in workbook example 2, and my answer to that is example 3. That's it for this section. I'll see you in the next one.